All right, this is video number 5. Video number 5 is going to cover the math tools. Okay, so the very first thing that I want to mention is that my math tools class used to be extremely ugly. I told you that this is where most of my work has gone into, because honestly, Andre, I'm not that great at the math. I'm very, very bad at it. But whenever possible, I try to clean up this math class. This is what it originally was. So as you can see on B-sphere collision, I call these same 3 lines repeatedly. Here again, here again, here again. It's just called all over the place. My collision against an ABB and an OBB was this massive thing where I just keep calling all the ifs over and over and over again. Granted, you do early out whenever possible, but just having all these ifs doesn't make sense. And the worst part is on the in the order where it was an OBB and an ABB, I do the exact same thing, because here it is, or here's an OBB and an ABB, and it's the same line. It's the same maybe 200 lines, and an OBB, same 200 lines. Some of these calls, like this closest interval right here is maybe another like 50 lines more or less, with just if else, if else, if else. This get min from sphere, or set the min ABB, as you can see, just it's like 10 lines too long, and etc. So most of my time went into cleaning up the math tools. So the lines that I showed you before, where you get a point and a radius, and you calculate if those two have intersected, I've set that into its own helper class. So a B-sphere will call this helper class given this information. I've left this in place because I need to visually see and understand this is radius 1, this is center 2, this is radius 1, this is radius 2. But this helper class is also called here in this other B-sphere collision against an ABB. Clamp is called so I can visually see that. I have to clamp my B-sphere to the min and max area of the ABB, and then check that collision. But I've obfuscated this the same 3 lines that I call over and over and over again into its own helper class. I did this basically realizing that I should never call the same 100 lines. This severely cut down this by an extra 3 lines, an extra 3 lines, an extra 3 lines. But I do leave these things so I can visually see and understand. I know that a B-sphere collision against an OBB is that I first have to get the OBB, set it into, I have to set my sphere into the local space of the OBB. I know that after that I have to clamp my B-sphere, just like this right here. And actually, in turn, I could just call this on a fake B-sphere. Regardless, I've minimized as much of this code as possible. The biggest exception, or the biggest example is there were 3 instances where I mentioned I called the SAT projection test, and it was maybe like 200 lines, as I showed you. Any collision that involves an OBB and an ABB is just brought down here. So since an ABB collision against another either ABB or an OBB collision against another OBB or an AABB is the same as saying 2 collision volumes. So I've set it so that if an AABB and an OBB, or the reverse, right here, or the reverse, ends up getting called, I have the ability to just call this function. I have all the appropriate information because it's the same as 2 bounding boxes colliding. The same thing happens on an OBB versus OBB, but I can see this more visually than the previous one. I have I get the center of my of my first box and my second box, and from that I get my 15 test vectors. From there, I call this projection helper. So given these 2 points, the axis I am testing on, and my 2 boxes, I do this. And I've also obfuscated a lot of this other stuff, like finding the length of a projection, finding the closest interval on V between our given boxes and the vector for this test. And again, I can always do an early out whenever possible. So when this becomes, when this returns a false, I'll take that false, have it become true, and I'll early out as soon as possible. But like I said, I have all these different calls whenever it's an OBB ultimately lead back to this one. So I don't have to chase back cleaning all these different calls. I just only have to change this one. And if my error is in here, I only have to change this one thing. If my error is in the length of my projection, I only have to change one line. So a lot of this was just cleaning things out. I've also implemented a lot of const correctness. Everything is constant references whenever possible. So I have my constant box, etc. And I just try to obfuscate as much of those with const correctness whenever possible. At my intersect, and other than this test, which, as I mentioned, I only do this because I visually have to see all these tests. But a majority of this code is in around the 5 to 6 lines range. My closest interval on V is another one that could also use an additional cutting. I just wasn't able to figure out how to remove this section where I try to find the quadrants or the octet on the closest interval for my V. But it's something that I know I'll go back to, and this is a lot more understandable to me than this calculation. I have many support methods, as I mentioned. So I have this this helper function, the SAT helper function. I have a clamp function, a function that gets the center of 2 points given a min and max vector. So I can just find the center of that very easily. My projection right here, another helper function. All these are private, so that way the user basically would only call all of these test commands. I also made these available because they tend to pop up a lot, getting the scale from the world, as I mentioned, when you have to deconstruct a matrix and get the scale. This is just easier for someone to implement than to actually do all the math. And I tend to get the min and max points from spheres constantly through all of the visualizer and all the collidable calls. So this was helpful to put in there. Yeah, and you're right. I'm probably going to look back at this a million different times, but I try to, I make sure I don't duplicate code in this one, and that each method only does one thing. And most of the time, as I've shown before, my methods tend to just call another method that simplifies the process. This method calls here, this method calls there, that method calls there. My OBB against a B-sphere, that just calls up here. It's just called the reverse. So again, I only have to change one area, and the effect of that will propagate to all the other ones and ensure that I only have to change the minimum number of lines possible for my calculations. But that covers that. As I said, I put in a lot of work for this math tools because I'm just not good at the math, Andre. I'll be the first to admit it. I'm not good at it. It takes me a lot longer than Spencer or Ian or anybody else. But I tried to make this as concise and as effective as possible because I'm going to be one of those people who's going to look back at this minutes before an interview.